Ready? Give me the signal. Okay, so now we're ready for part 2. This time you're not measuring pressure with respect to volume, but pressure with changes in temperature. So we need a little different setup to be able to change the temperature. This all still connected the same way you had it before, but I've taken off the syringe. I restarted Logger Pro. We're back to the default setup here, so you notice that it's back to time and pressure. We're going to have to change that. But we're going to set up our apparatus first of all. We need a few more things from the box. So the box in here, there are a few other things sitting around in here. We're going to need this longer tube, and it may be in any number of different arrangements of parts. We're also going to need this rubber stopper that looks like it has 3 holes, but it actually only has 2 because one of them is sealed shut. And this little valve, blue valve with this adapter part on here. Both of these conical shapes go down in the open holes, so it doesn't matter how you put it in there. Exactly, except you probably want to put the valve away. There. Should look like that, and you should make sure those are in there nice and tight. You don't want any air leaks. And we can check on that here if we need to. That's the start of it. This end connects to the gas pressure sensor. So we have it set up, looks something like this. So you're reading the pressure at this point, and that point is connected to the bottom of this stopper. So we need to be able to measure what's going on here, and we're going to do that inside this 125 milliliter flask. So we're going to take this, and we're going to put it on, and we're going to give it a little twist. Now that's solidly connected there. You'll notice when I did that, the pressure went up just a little bit, right? It doesn't say 100 anymore, it says 103. Because when I put that on there, I sort of pressurized everything. So let's see what happens. Put this right here like this. Let's hope this works. When I open this valve, I don't know if you guys could hear that or not on the video, but a little bit of gas escaped and the pressure dropped back down. So now, at room temperature, whatever temperature we're at here, the pressure inside this flask is the same as the pressure in the room, 100 kilopascals. So now, whatever temperature I make this flask, I will be able to read what the pressure is that corresponds to that. And it's the volume can't change because everything's sealed up. So it's always going to have the same, the gas that's in here, the air, is always going to have the same volume, but we're going to make it hotter or colder, and that hopefully will change the pressure. So how are we going to adjust the temperature? Well, I have here my handy dandy water bath. It's a 600 milliliter beaker that I have arbitrarily filled to just below 400 milliliter of water. Remember, these are very approximate, so this is not important. You do not need to make it exactly that volume, but about half full usually works pretty well. I can take this, drop it in there. That's about what you want to see. You want to see the majority of your flask underwater. Right? Because you want everything in that flask to be at the same temperature. And if so, whatever temperature the water is, the whole flask is in contact with that temperature. So now, if I were to adjust the temperature of this water, so if we look back, this water's at room temperature. So if we look back at the pressure, still at 100. If I want to know exactly what that temperature is, that's an important part of this experiment. We need one more piece of equipment. We're going to have to travel for it because I forgot to get it out before we started. We're going to let that go. It's going to float a little bit. That's all right. And over here, up in that box up there are, thank you, Dr. Cutler, the temperature probes. This is a very fancy Vernier model thermometer. You'll notice it has the exact same kind of fitting as our gas pressure sensor. So guess where that's going? Right back over here, channel 2. Click. It's in. And if we look here, give it a second, I have 2 things now. I have pressure and I have temperature. I'm reading both of those things. So let's set this up. If I take my mouse, go to experiment, just like in part 1, data collection, not time-based, events-based. So what do I want? What event do I want? I want the event to be temperature. So I gotta type that in. Temp, good enough. And so now you see over here, we have a temperature, pressure, and it's going to measure the temperature to tell us what that is. So really it's these two columns we're interested in. But again, we've got collect and keep right there, just like before. So if I take my temperature probe, I'm going to put it in the water, because the water is the thing that tells us our temperature. And if you notice, I put it in there, the temperature's mildly changing, not too much. You want to give it a minute. That last decimal place, just like any of the other measurements we make in lab, it's not always going to sit perfectly still. It may wander up and down a little bit. You see the pressure is doing that right now. That's okay. Do not wait for every number to totally stabilize. You'll be here for a month. So now we've got it. So this could be our first data point. So we could say collect. And we could say keep. And I can just write whatever the temperature is. So in this case, it's 20.9. And say OK. And so now I have pressure at 100, temperature at 20.9. I need to get some other temperatures going here. So how am I going to achieve different temperatures? I have two methods for achieving different temperatures. I have a hot plate. This hot plate is not on right now, so if I put it on there, nothing will change. But if I adjust this knob, it has a temperature dial that's approximate. Get out of the way for a second. So it should start heating up. If I were to take this water bath and put it on there, my temperature probe will monitor how that temperature is going. Be careful when heating these things up. You do not want your temperature probe all the way on the bottom. You don't want it touching the bottom of the flask, so it needs to be a little bit off the top. Maybe take your flask a little bit off the bottom so nothing's in direct contact with the hot plate, because that'll be hotter than everything else. And we don't want to. We also want to make sure that this cord. No. See, oh, look at this. We picked a great one. Somebody has already had to repair this with a little bit of electrical tape because it got too close to the surface of this hot plate. Plastic coating, hot surface, bad combination. That will melt. So pay attention to where this is, and keep it away from the hot plate. So that's if you want to make the temperature warmer than room temperature. We'll let that heat up for a bit. If not, if you want to go the other direction, we'll have ice available in ice buckets. It'll look like this. It'll come down from, we'll have that. And so you're just going to take a little bit of that ice. This is easier one than the hot plate. This works a little faster for what we're doing. Drop it right in there. Remember, this water bath is simply a way to change the temperature. You can put the ice directly in there. The volume doesn't matter. And if we look now at our temperature, it's going down a little bit. And what's happening to the pressure? It's changing as well. That's what we're trying to measure here. So you'll add a little ice. We'll try to get to a stable spot for that temperature. And then we can record another data point. Give this another minute. That hot plate's starting to get hot. Be careful as your hot plate starts to get hot that you do not have anything nearby that could melt and or catch fire. So these might be a little bit of a trick. You may need to watch it. It looks like it's leveling out now at about 16, so we're gonna keep that. Turns out I stopped it at 15.9. Say okay, now I've got two data points. All right, they're pretty close together. So to get good data here, you may need to vary over a reasonable range of temperatures. One of the things in the lab handout tells you to work with some other groups and coordinate your data collection. So maybe you'll pick a range of temperatures you want to work at, and then the group next to you picks a different range. And then you can share your data so you can get a wider range. Let's see how we're doing here on the old hot plate. I'm going to set this on. It may sizzle a little bit, the water underneath. Now this won't be instantaneous. Water, as you will learn a little later in the semester, is really hard to heat up. This is going to take a little time, especially since I made it cold first. So we're fighting that battle. But you can see we were down at 15.9. We're already heating up. We're at 17. It's going to change. Now it's really cooking. And you'll want to get it to whatever temperature you've specified. Please don't stir with the temperature probes. We have glass stir rods if you need to stir. And when that gets to whatever temperature you want, you collect another data point. And when you've got 5 or 6 different temperatures between you and whatever other groups you're working with, We'll call it interesting and good data. That's part 2.